So the question tells us the plane equations for plane P, Q and R, where mu is a constant. Part 1 tells us, given that mu equals 3, find the coordinates of the point of intersection for plane P, Q and R. So to start with part 1, we'll start with, given that mu equals 3, alright, to find point of intersection of 3 planes, what we do is we solve the 3 equations using our GC to find the solution. Alright, because the common point between the 3 planes will be the solution of the 3 equations. So we will first write out equation of plane P, x minus 2z equals 4. For plane Q, 2x minus 2y plus z equals 6. And for plane R, 5x minus 4y plus 3z, where mu equals 3, equals to negative 9. So to solve this, we use our GC. So by GC, we go to our equation solver. Alright, since we have 3 equations and 3 unknowns, we use this mode. We'll key in all our figures and we solve for our answer, which will give us x, y and z. Okay, so we transfer this into our answer sheet, where x equals to negative 38 over 3, y equals to negative 109 over 6, and z equals to negative 25 over 3. Alright, since question is asking for the coordinates of the point of intersection for PQR, we have to represent our answer in terms of coordinates. So we write the answer statement. The point of intersection is negative 38 over 3, negative 119 over 6, and negative 25 over 3. Alright, something to note is that we don't write an equal sign here. When we represent coordinates, we don't use equal signs. Alright, now moving on to part 2. Given instead that mu equals 0, so for part 2, mu has a different value, so we'll write that down. Given mu equals 0, describe the relationship between P, Q and R. So to find relationship between 3 planes, we always have to check, first thing is whether they are parallel, second thing whether they have intersections. Alright, so we will first write out the 3 plane equations. X minus 2z equals 4 for plane P. For plane Q, 2x minus 2y plus z equals 6. For plane R, it will be 5x minus 4y equals negative 9, since mu equals 0. Alright, now if we notice, the normal for plane P, alright, normal for plane P is 1, 0, negative 2, while normal for plane Q is 2, negative 2, 1, alright, from taking the coefficients of x, y and z. And the normal of plane R is 5, negative 4 and 0. As we can see, none of them are scalar multiples of each other, so no 2 planes are parallel. Alright, next thing that we check is we check whether there are any solutions for these 3 equations. So we will use our GC again. By GC, we'll go back to our equation solver. 3 equations with 3 unknowns. Alright, we don't have to change much, only the final mu value for plane R's equation, where the coefficient of z is 0. Alright, then we can solve for the equation. As can be seen, GC shows that there are no solutions. So by GC, there are no solutions. Okay, when there are no solutions, there are 3 cases for the relationship between 3 planes. First case is where all 3 planes are parallel. Second case is where 2 planes are parallel but one passes through the other 2. And the third scenario is where the 3 planes form a triangular prism. Alright, in all these 3 cases, there is no common point between all 3 planes. But since we already proven that no 2 planes are parallel, so it cannot be the first 2 cases, it has to be the last case where 3 planes form the triangular prism. So to describe the relationship between P, Q and R, what we will say is that the three planes form a triangular prism.